Greetings, judges. We are Team Spectra 6. Our problem statement title lies under Student Innovation, which is development of Tri-HQ, a next generation optical EMS triage device to overcome limitations of conventional oximeters in diverse field conditions, which comes under the theme of medtech, biotech, or health tech. Imagine an accident. A paramedic arrives and uses a conventional oximeter on a patient. The SpO2 level is normal, the heart rate is a bit high but stable. The patient is marked as safe for now. But what the oximeter couldn't see was a slow internal bleeding. The body was compensating, keeping the oxygen level high until it couldn't anymore. By the time the patient crashed, it was too late. This isn't a rare story. This is the fatal flaw of conventional oximeter, which we are going to solve. Conventional oximeters are blind to the most critical vital sign, blood flow. That is the problem we have solved. TriHQ is not just another oximeter, it is a perfusion monitor. While a normal device gives you 2 parameters, our device provides 5, including 2 revolutionary metrics. First, the perfusion index, PI, which measures the strength of the pulse. This tells the paramedic if their reading is even reliable. And second, our core innovation, the blood flow index, that is BFI. Using an advanced optical technique called laser speckle analysis, we can measure the actual speed of blood flowing into the capillaries. This allows us to detect the earliest sign of shock, long before the oxygen level drops. We are turning a blind spot into a life-saving data point. We are developing a robust hardware prototype of TriHQ, the quantum-inspired smart oximeter designed for EMS use. The embedded software is built primarily for real-time signal acquisition and analysis on the device using ESP-IDF firmware, implementing advanced photonic sensing algorithm such as lock-in correlation, PRN-coded illumination, and BFI computations. Our backend and front-end software tools serve mainly as support systems for testing, data visualization, and validation. This hybrid approach ensures the final product is a physical medical device ready for use, with software components enhancing development and demonstration. The result is a low-cost, made-in-India hardware device that empowers paramedics with objective, real-time triage capabilities, dramatically increasing patient survival chances during the critical golden hour. This technology needs a home. As you can see, we are in the stage of our hardware design. We have focused on a single button device that's tough enough for any emergency scene. And while hardware is being finalized, the most important part, the firmware and UI of the device is 100% complete and operational. And now I am going to show you it's working by connecting it to our hardware sensor and running a live test on a real person. This is the TriHQ software. I am selecting the live sensing mode to connect directly to our sensor. The software is now connecting to the hardware. The link is stable. I am placing the sensor on my volunteer's finger and the analysis begins automatically. What you are seeing now is the raw optical data streaming from the patient's finger. But look closely. Our software isn't just displaying it, it's analyzing it. Each glowing dot is a confirmed heartbeat. And this overlay shows the heart rate being calculated live from the data. This proves that we are processing a real signal. Okay, the system is acquiring data. Initial readings are stable, minor triage. This is what a normal oximeter would show. But our system is analyzing the blood flow, the BFI. Let's see what it tells us. And there we have it. The blood flow index is stable and in the green. So in this case, the system has not only checked the oxygen, but it has actively confirmed that the patient has good circulation, ruling out hidden dangers. The final triage is minor. Now let me show you the science behind that BFI reading. This is our core technology at work. We use laser speckle analysis to calculate the blood flow. As the formula shows, the BFI is derived from the speckle's decorrelation time or tau c. This is a direct measurement of blood speed. This is not just a feature, it's a new paradigm in pre-hospital care. And alongside this, we also calculate something called perfusion index or PI. The PI is a quick measure of how strong the pulse is at the fingertip. It's calculated from the PPG signal as the ratio of pulsatile flow to the baseline flow. A higher PI means strong peripheral circulation, while a low PI means weak perfusion. For our triage, anything below 1.5% raises concern and below 0.5% is critical, often seen in shock patients. So here, with a normal PI value, we now have 2 confirmations. The BFI is stable and the pulse strength is healthy. In addition, we are showing the 30-second trend for heart rate in real time, giving you instant feedback on stability and changes. Likewise, the display includes current SpO2 levels and respiratory rate. So every major vital is continuously monitored. Finally, take a look at the signal trust score at the bottom. This confirms that the sensor data is reliable and each value on screen has high confidence for safe clinical use. And that completes our demonstration. With all the major vitals analyzed and validated in real time, you can see exactly how our device transforms critical data into confident triage decisions right at the scene in seconds. Thank you.